Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at the ACT and trying to help you diagnose some of your students' areas of weakness. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. Tonight, we're really lucky to be joined by our two panelists. Fresh off the slopes in Colorado is Jeff McCullough, and with him is Tom Reardon. Jeff co-founded the TI-Nspire Super User Group with Bryson Perry some years ago. He currently teaches Algebra 2 and AP Stats at St. Mary's Episcopal School in Memphis. In 2009, Jeff received the Presidential Award for Excellence in Math and Science Teaching. Jeff also is the author of the second edition of TI-Nspire for Dummies, and also the second edition of the TI-84 for Dummies. And important for tonight, Jeff is a co-author of the ACT and SAT prep courses for T-Cubed. Jeff, you're probably a little jet lagged. Thanks so much for getting here safely.
Well, I'm glad to be here, and I think Tom's probably happy to be here so he doesn't have to do this alone. So,
very true. And speaking of Tom taught at Fitch High School in Austintown, Ohio for 35 years and served as an adjunct professor at Youngstown State University for 39 years. As a T-Cube national instructor, he has worked on the development of many things, including transformational geometry activities, ACT and SAT prep courses, and since 2009, Tom has been working as a senior math advisor for TI, currently working on the Families of Functions video series. Tom, it's great to have you with us.
Yeah, good to be here, and I'm really glad Jeff made it back.
For the backstory, Jeff was traveling, and we actually didn't know if Jeff was going to make it here tonight, so that's what the back and forth is about, so we're happy to have Jeff here. We're expecting a large crowd tonight, so your audio is muted. Feel free to send any questions to Jeff or Tom using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event's certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, at the bottom of your screen is the audio broadcast icon. Try toggling that on and off. At this point, Tom is going to discuss our agenda.
Okay, so we are going to do some ACT problems, no doubt, discuss and illustrate test-taking strategies, emphasize the importance of students doing the modeling practice problems, illustrate appropriate and effective technology use, and get several ACT practice problems used with your students beyond what we can do here tonight.
Good stuff. And then, Tom, would you mind talking through our expected outcomes as well?
So, yeah, you're going to see and experience what types of problems are on the most recent ACT tests, share effective test-taking strategies with your students, learn how to efficiently incorporate technology as a teaching and learning tool, not just for the ACT, and feel much more comfortable and confident about what is on the ACT when working with your students.
Tom, thanks so much. All right, Tom, you should have control. Feel free to share your screen.
Okay. And I'm going to turn on my video. Hope that doesn't scare anybody.
Looking good.
All right. So you can see it all right?
Yep.
Okay. So first of all, happy St. Patrick's Day, a day ahead. I am somewhat Irish, and so I got it on Inspire, the 84 color, and the 84 grayscale. All of this, you can get how to graph these at this website, which will be up on the next couple slides. If you are interested in March Madness mathematics, I got some things up there for you. I'm calling it March Mathness. I'm not sure if that's going to work, but it's there. Okay. And so all materials, problems, solutions are available at this website, including, since I wasn't sure Jeff was going to make it, I did like 20 more problems and I put them in my solutions. So You're getting them. I don't have any use for them, so you're getting them. So my goal is that my students can solve each problem by hand. That's my goal. But on a high stakes exam like the ACT or SAT, if technology is allowed, and it is completely on the ACT, I want my students to use the technology to assist as needed. But I want them to be quick and efficient with it. So I'm going to be showing you a shortcut or strategy that seems to displace the math sometimes, but I'm showing this as a last resort for students. And on these types of exams, only, okay? So, because when I tested, I had like a go calculator, no calculator part. You will be given only 15 or 20 seconds to read the problem when I'm doing it and begin to plan a strategy to solve it. I'm not going to have time to finish it because I have several different ways I'm going to show you, and I'm going to show you those things. You can kind of solve them on your own, your way. So please don't get angry with me because you want more time. And I understand that, I get that. But if I do that, you'll see 3 or 4 problems instead of hopefully 10. Sometimes I'm going to illustrate with an 84, sometimes the Nspire, sometimes both. But I know that people are here for both. So the solutions on the solution slides have both the by hand, not the by triplicate, by hand, the 84 solution and the TI-Nspire solution. So you get all of those. So if you say, oh, we went too fast, you've got the solutions in perpetuity, okay? So we're good there, I think. All right, so with that, I'm gonna go ahead and get started. So this is one of the things, and Jeff's gonna talk about all 6 of them, I think, when he gets to it, because that was on his slides. But we're gonna look at number and quantity. And so this is our first problem right here. You've got 15 seconds, and then I'm gonna come back in. So just kind of get a plan, 15 seconds.
And I thought you were going to give us a hard one, Tom.
No, 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 not to start. So this one right here, I mean, traditionally, not an issue for anybody on this, I would hope, okay? But you can see how these got the wrong answers here, how that happens. But I thought I'd show you how you could test this out by using the calculator here. So I'm going to go ahead and bring up the 84. And one of the things, I actually learned this one from Jeff, was to use numbers to evaluate. So I'm going to store 2 into the letter B, or the variable B. And then I'm going to evaluate the original expression. So I'm going to get myself a fraction template and type in B raised to the 12th power in the numerator. And then B raised to the 3rd power in the denominator. And then when I press enter, it's going to evaluate that with the current value of B, which is 2. Now I can see A doesn't have a chance, but I'll try the letter B, B to the 4th. So alpha B raised to the 4th. And it's going to take that current value, and it's too small. And then I'll try alpha B and raise it to the 9th. And bingo, there it is. So I'm going to pull that slide off so you can see it, okay? Because it might have been a little difficult to see there. So that's how another strategy you could have with students, to double check to show why that's the answer also. And then also, if you do it on Nspire, it would look like this, okay? And this is what the answer solutions things are going to look like. They're going to have the traditional, the 84, and the Nspire. So that was an easy one to start.
Really nice for students, Tom, because sometimes they just kind of like go blank on a test. They know the exponent rules going in, and then they just kind of forget them. And so if they're kind of debating between B or C or something like that, they could always just test it by plugging in a number.
Yeah, and I mean, this is just a good way, even just to double check, even if you know how to do it. It kind of also affirms it, why it's the case. All right, number 36,
Daniel
another
had an
fairly
idea.
easy
He said you could even graph that one with X's.
Yes, yeah, you could graph them and see which ones are identical, equivalent forms of each other. Sure. Hi, Daniel, how you doing? So number 36, again, I'll give you about 15 seconds there. Give me your best shot. Okay, in 3, 2, 1. Again, I'll show you the traditional way, just kind of multiply two binomials together. Remember that I squared is -1, turns right out. But what amazes me is that on either calculator, you could type this into the calculator and it does it for you. It doesn't matter what mode you're in. You can be real, you can be an imaginary. But if you just type left parentheses, 8 minus 5i, and I, by the way, is second decimal point is where you get the imaginary I, the quantity squared. It's that easy. And so, Jeff, it just shocks me that this is still on the test. Because every single problem can be on the calculator, okay? And similarly with Nspire, you get the I from the imaginary I from the pi key, not the letter I, the imaginary I. So again, the same results. Yeah.
And you don't even have to change the mode in the calculator. I mean, it can be in regular mode and, just type it in. It's amazing.
Right. And also other things it'll do like realize the denominator. If you've got like 2 plus I over 3 minus I, it'll make that denominator a real number. So yeah, it does all of those things, which is just amazing to me. All right, number 40, probably gonna take you 20 seconds to read it, but at least get an idea of what it is. So when I show you some solutions, they'll make sense. So got 20 seconds, go ahead. All right, coming in 3, 2, 1. And this one here, I look at this as units conversion. And Jeff, when you and I did SAT, they were more prevalent, I think, on SAT. And this one kind of pops up here. So I write this 2816 feet over minutes, okay, as a rational expression, times 20 seconds over 1. And then I'm going to multiply by expressions that are equivalent to 1. Because when you multiply by 1, you don't change the value, but I'm going to change the appearance. And again, you would talk to your students about why 1 minute over 60 seconds is so that the minutes in the numerator here, the minutes denominator here divide out and make a 1. I keep using the word 1 here. And then 1 meter over 3.3 feet was supplied for us here so that the feet would divide out and leave us only with meters. So when you do this, I like to show that these do actually make a 1. I'm not slashing them, getting rid of them, obliterating them. And then you go ahead and multiply this out. And when you multiply it out, it's pretty much just using a fraction template, 2816 times 20 in the numerator, and then over the 60 times 3.3, well, I'll do the 3.3, I guess, times 60 in the denominator. And you're getting the number that's closest to 84. So,
and Tom, I noticed you got to the fraction template a little faster than some folks. How did you do that?
Okay, so there's 2 ways. Alpha y equals gets you the fraction template, okay? And then the quick way on the color, if you have the latest operating system, it's alpha x t theta n. Alpha x t theta n will get you the fraction template the quick way. Good call. All right, and then this is the Nspire, same way. It's done very similarly, not much change there. All right, number 58. Now we're getting to some good mathematics here.
Oh,
so
wow.
20 seconds, got just to get a start. All right, in 3, 2, 1, and I know that's not enough time. Don't get mad at me, please, okay? So in order for this to have no real solutions, its discriminant has to be negative. And recall, b squared minus 4ac has to be less than 0. But in this case, b actually is the variable k, and a and c are both +2. So when you do that, you get down to this expression here, and most people would probably factor it and then do the number line chart and get letter E, and that's fine, okay? But some students might get to here and not know what to do or remember what to do. So one of my favorite things to do is to go back to y equals, and I'll clear all this stuff out here. And it looks like I'm in transformation. I don't think it'll make any difference. So I'm going to go ahead, instead of k squared, I'm just going to type in x squared minus 16. And then I'm going to do something that, if you've not done this before, really looks wrong. I'm going to type in second math for test. This is where the inequalities live, less than 0. And if you've not done this before, let me explain what's going on. I'm using something called Boolean algebra or Boolean logic, and it's going to graph either y equals 1 or y equals 0. When y equals 0, it's going to be false, and when y equals 1, it's going to be true, okay? And I want to know when it's true. So let's go ahead and do a zoom standard, a zoom 6. And you can see right there that this is true between 1, 2, 3, 4, and -4. In fact, maybe it might be clearer if I change this to so that the detect asymptotes is on. Oh, probably because I'm in the transformation app. Let me get out of the transformation app.
Oh yeah, that's probably.
I think it'll look a lot better if I do that. So let me go over and turn that off. Sorry about that. So let me graph it. Yeah, so now I'm getting it much clearer there. And you can see clearly that x is between -4 and 4, or in this case, k is between -4 and 4. So I like that idea for inequalities. On Nspire, I typed in x squared minus 16 is less than 0 on the relations graphing, and I got this kind of cool looking thing. And you can see clearly it's not including the 4 and -4. So, you know, thought that was kind of cool to illustrate that.
That is really neat.
Okay. So second thing on this is algebra has about 8 or 9 questions per test. And this one right here, again, I'll give you about 20 seconds. Give me your best shot. Coming in 3, 2, 1. And we'll look at the traditional first, okay, which I don't think you'll have any problem with. Add radical 2 to both sides, divide both sides by 3, but unfortunately, that answer is not here. We have to use what's called an equivalent form, and as Jeff and I both know, equivalent forms are a really big deal on both of these tests, and so this, of course, is the answer, right? But again, one of the things that Jeff taught me was we could just, by brute force, figure out which answer is correct. And I'm going to do something. I have a couple different ways listed in the answer sheets. I'm going to show you one way. I'm actually going to type this into y1, but I'm going to use x instead of y. So I'm going to type in 3x minus the square root of 2 in for y1. Okay, so that's going to be in y1 right there. And I'm going to evaluate y1 at each one of these expressions to see which one gets it to be equal to 6. Let me make this so that it's always in front so it keeps jumping on me. So when I go off to the home screen, alpha trace is the quickest way to get to the y variables, alpha trace. And so I'm going to take y1 and left parentheses, evaluate it at the answer in A, 2 minus the fraction template, radical 2, oops, sorry about that. Radical 2, went to the wrong spot, all over 3, get out of there and right parentheses. And when I evaluate it, I'm close to 6, but not close enough. But so I don't have to keep typing. I'm going to go back through the history and highlight that, press enter to paste it down. And now I can edit that and change that minus to a plus because that's the answer in B. And bingo, that was it. So here's a way of, again, if students say, oh, I'm not good with radicals or whatever, or they don't realize it's a linear equation even, this would be a way to do this. Also, it's a way to check your answers. And when I did it another way, go ahead, Jeff.
Josephine had a question about second trace. I think he hit alpha trace to get the y1 there. Alpha trace is the shortcut for that.
Right, alpha trace, good. And so I, by the way, showed all of them, ones that didn't work, okay? And then in On Inspire, how it's different on Inspire is I actually defined a function, f of y. I used the variable y as that expression on the left. And then I did function notation, f of each one of them to see which was 6. So, and define is the very first command in the very first menu, actions. So hopefully that worked out okay. All right, this one here, kind of a quick one. I'll give you 10 seconds on that one, see what you can do. Okay, and 3, 2, and I don't think this is an issue for any of you here. I mean, 108 million, I'd write that with 108 with 6 zeros. But I got to back up 8 places to get a number between 1 and 10, and that's it. I mean, it's that simple. But you could also do this with a calculator if you change the mode to scientific. So I'm going to go over to SCI and change it to scientific mode. And now when I type in that number, 108 with 1, 2, 3, 4, 5, 6 zeros, 108 million, it gives me the answer in scientific notation, 1.08, and this E is times 10 to the 8th power. So now Inspire doesn't work as well with that, Jeff, unless, Jeff, you could think of a way that does. I just kind of just did, kept doing the answers until I got 108 million, but I don't think this will, it didn't seem to work like it did on the 84, while I would have it in scientific notation, it didn't put it in it for me.
Yeah, I mean, I agree with that. I think if you know a little bit about scientific notation, you can eliminate A and B, because, you know, we're big on that elimination thing. Daniel mentioned that. Right. I think that's a really good idea. Yeah.
And a lot of kids, I think, would have gone with C just because they'll see the million and go, oh, that's 10 to the 6th, bingo. And yeah, falling for the, you know, we call that falling for the halfway answer. So just be careful.
Yeah.
So yeah, Daniel's got some good ideas. So let's see, I'm on 30. So he gets a virtual Pez. Where we go. And back to 30.
Nice.
All right, so this one right here, this one is a little nasty. You definitely aren't going to be able to do it in 20 seconds. Well, if you can, I'm amazed. But see what your plan would be for something like that. Equivalent expressions. And in 3, 2, 1. And traditionally, I'm sure none of you have trouble with this. Traditionally, though, I did divide out of 5 in the last fraction. I thought that was a good idea. And then, you know, got the common denominator, and, you know, just like we would teach in either later Algebra 1 or Algebra 2. But sure. Another way to do it would be to, as I've been doing before, evaluate this expression with a number, and then evaluate these with that same number and see which were equivalent. And one number I would probably stay away with, maybe not so much on this one, is 0. 0 and 1 I usually don't like to go with, so I think it works on this one, because 0 and 1 can sometimes give you false sense of security. They might work, you know. So I'm just going to use 2. So I'm going to take 2 and store 2 into, and I could use either X or N. I'm going to use N just because, so you can. Oh, looks like I'm still in scientific notation, so let me go back to normal mode. Let me do that again, so I'm just a regular 2. Now typing this in, I'll agree, but I've got some kids who'll say, I'll gladly type this in instead of having to do this. And I'd say, well, on my classroom, you're not going to be able to do this. You should be able to do this by hand. But for this, you should be able, you know, if it's on this test, you know, if everybody's allowed to do this, take advantage. So
you know,
I'm going to evaluate.
David mentioned he likes using a number like 1.1 just so it's really weird, you know, so it won't usually give more than one correct answer.
Right, and that's a good idea. Unless it gets really weird, then you get so many decimal places it could get weird. Okay.
Yeah. True.
So I got -4. I got -4, and so for this next one, I will try 9n minus 14. And again, it is some typing. But if you have no idea how to do this, and this test is a high stakes test, then by all means do it. and evaluate. Boy, I really lucked out. Well, I didn't luck out. I knew it was going to be that answer, but still, how nice is that? Okay, and I can feel pretty confident with that.
And, you know, Daniel mentioned if you plug in 0, you can eliminate some answers really nicely there. So sometimes it can be
eliminate all
faster.
Of them?
Yeah. Does
it eliminate all of them? Still, you got some fractions.
0 works well in this because we need to have 4 2/3 greater than 1, and only one choice evaluates giving an improper fraction.
Okay.
So it's yeah, I mean, it can really save some time there sometimes plugging in 0.
Right. And so here's my Nspire version with 1 going in for n, and you got, you know, different answers, but equivalent ones still.
Yeah.
Here's another toughie. This is the last question on one of the exams. Okay, so I'll give you 20 seconds just to think about this. And I've got a couple ways that are a little different. So I'm curious what you think. So 20 seconds. And 3, 2. Okay, so again, traditionally, it took me a little while. I tried to factor this, and I knew that one of the factors was x plus 2 because of the factor theorem. The root is -2, the factor is x plus 2. When I also knew that this had to be a -3 to get the -6. When I multiplied it out, the linear term has to be equal to 5x. So I could go ahead and find out what c is. And c turns out to be 4. And so the only thing that's going to work then is 4x minus 3. And notice that's not one of my answers. Creeps that they are, sorry, people that they are, you have to factor out the 4 and get this as your linear factor. And that's fine. I would hope my students could do that without any issues. But I came up with a couple ways on a calculator, and I'm curious, Jeff, even what you think, because I'm not sure I even shared this one with you. So I'm going to go back to the transformation app.
Okay.
And I'm going to type in that expression right there, alpha c times x squared. I don't need the time sign, but I like it. Plus 5x minus 6. And whenever you use, you're not sure what the variable c is. So I go out to the home screen. This is how I do. I put 1 and store it into c so that I know where I'm starting. That's just me. You don't have to do that. So when I graph this, c is equal to 1, okay? And now I'm looking at this thing, and I want to know when is the root going to be -2, and you can see I'm not even close to -2. So I'm going to go ahead and increase c to 2. It's getting closer. To 3, we're getting closer. And to 4, there it is. I've found where this is -2. And my other root is going to be between 0 and 1, and the only one it could be then is f. So I used the transformation app to help me solve this problem because I couldn't figure it out algebraically.
Of course, synthetic division might work there as well, Daniel said.
Okay. Should he join us the next time we do one of these?
Maybe that might be a good idea. If you get sick of all the paths.
Okay. And then on Nspire, I did a similar one on Nspire where I created a slider and similar idea, but I just used a slider instead of using a transformation app and just kept sliding over until I got the solutions there. So, all right. So let me just, I think there's one, I'd like to show one here, and then I'll turn this over to Jeff here. So this is on functions, manipulate, translate functions, function types, so on. And one of the things is, can you do transformations, but to make it the game like level playing field, they'll give you a piecewise function that nobody maybe has ever seen before. And so now what you have to do is be able to translate that, okay? So let me give you 15 seconds, see what you can do, and then I'll finish up with this one. And in 3, 2, 1. And so doing this, let me do it by hand first. I'm just going to pick one point to start with, and I'm going to pick with this one right here. And what I'm going to do is move it to the right 3 units, shift it to the right 3 units, because that's what this says to do. And this says shift it up 2 units, so that's what this says to do. And that point then lands at 0, 4, so I have to find which one of these starts at 0, 4, and it turns out to be this one, okay? Now, every single point is going to be shifted right and up, but if I just pick one, and hopefully that's the right one, that should do it. Now, what I did, and I'm just going to point it out because I'm running out of time here, see what you think. I made up a function that was the first part of this, -1 minus x, and graphed it in black. You can see it's like this part right here. And I graphed that, and then I typed in y1, y3 of this, what I wanted, x minus 2 plus 2, x minus 3 plus 2. And it ended up at 0, 4 to start with. So I kind of used the calculator to do the translation for me. So anyway, and I did the same
domain
thing.
there. That is that a piecewise function with one piece?
Yes, right, exactly.
Oh, okay.
So you can go from 5 and down to 1, and this is a limited domain function. You're right. So yeah. I just thought I'd do that, and I did the similar thing on Nspire. Nspire is a little bit, I think, easier to do it with, but I just did that with Nspire. So anyway, so I know we didn't get to a lot of the other ones, but trust me, they're all in there. You know, you'll be able to see them. They're all there. Check out this one because I was able to use a graphing calculator on this one. Really cool. But I'm going to turn this back over to Jeff. So thanks for listening. And Jeff, so I'll pass this over to you.
Okay.
I can find you. Let me see. Can I find you? Yeah. Can you grab it, Jeff? Because I'm having trouble. I hid
me. If I can grab. I don't think I can. Oh, there it is. I have it now.
Okay. Okay, good. Go ahead. And then I'll watch the chat and.
Okay, I think we're there. Okay, so let me get rid of that. Okay, so let's go to, actually, let me show you one thing here that Tom mentioned. So I don't know if y'all are aware of this, but every single ACT test has this at the end of the test for mathematics. So it says, you know, it has a mathematics scoring key, which you've probably seen before, but you know, after about 2016 or so, they started putting this, you know, N. Tom, you did that one. I think that was the numbers one. A is for algebra. F is for functions there. G is for geometry. S is for stats. And then there's like middle school mathematics problems as well there, which is the MID, MDL kind of stuff. Or that's modeling, sorry. The IES is the basically middle school stuff called integrating essential skills. So they break it into 6 categories, basically. The modeling category there, if you see that, is like, is it like a real world problem? So about 30% of the test is modeling. And so this is helpful because when students get their scores, I don't know if you've ever seen this, but they give you a percentage for each, you know, anytime they take a test, they'll give a breakdown percentage, like you got 40% right in geometry, but you got 80% right in stats or something. And so you can identify or diagnose kind of students' weaknesses by looking at what the ACT says they're weak in. But if you don't understand these 6 categories, it doesn't really help you that much. So Tom went over the first 3, the numbers, the algebra, and the functions, and I'm gonna go over the geometry, the stats, and the integrating essential skills, which is like middle school math kind of stuff. And they tell you about how many problems are gonna be on each one. I'm just curious, do any of y'all use this at all? Have you ever seen this before or used this with your students to help diagnose their problems?
You just put a Y for yes if you have. Only since
Or how have
attending
you
your
used
session.
it?
So
Yeah.
we've had 3 say yes, 1 is not, didn't know about it, no, yes.
And so even if you, like, the ACT even offers, you know, like they have a 2021 free ACT test. And if you have a student take it and you look at the end here, you can actually diagnose which areas they're weak in. And you'll see this with certain students. You'll see that some of them, you know, are just, they hate geometry and they don't do well in geometry, or vice versa. Sometimes they're really kind of not that good in algebra, but they're pretty good in geometry. Or a big weakness for a lot of our students, I think, is sometimes the stats area. It kind of depends on what your books have in there, stats-wise. But a lot of times, you know, you'll see like a definite weak area or a strong area. And that, to me, especially if you're tutoring one-on-one or helping students to diagnose themselves, you can just Google ACT free practice test, and Jeff asked that question, and you'll see a number of different PDFs that come up. There's some official ones and some non-official ones that will come up. But even if it's a released test, so if your students take the test in April, June, or December, typically last year was July, but they release those tests. You can pay like about $20 as test information release, and the students get the test sent back to them, and they can actually, you know, see which ones they missed and see the breakdown. So you can diagnose their test. I think even if they don't pay for that, you get the results. You get this, I think, usually. They don't really take the test online. Someone asked that question, but you can print off a PDF of that. $22 is for the test information release. But this can be really helpful for our students to, again, diagnose what areas are weak in. A lot of the practice books you might see, you know, Princeton Review or some of those, they have like problems to work on. Like if you're weak in geometry, okay, do some of those geometry problems, do some of the function problems, the algebra ones, and so forth. So you can kind of break it down by category, which is, to me, pretty helpful. And so this is like with the geometry category, they kind of break down really rough. It's not like super specific here as to what is contained in all the geometry. For example, I was like, where's the angle? I think when it says missing values right there, that is, you know, one of those missing values can be an angle there. Sorry, I'm trying to get my pen to work. But one of those missing values can be an angle in a triangle, in a circle, et cetera. You got some basic SOHCAHTOA stuff. You have conic sections. These, some of you who are familiar with ACT have become more and more popular for the ACT, is the conic section problem. Students aren't familiar with it sometimes, and so they have trouble with that. So I picked a few problems here that highlight, let me try to get this off the screen, that highlight some of this geometry. So I'll give you a second to look at this one, and then I'll talk about it. And I really actually love this question. The ACT has been doing this kind of question more often, and they love to boil things down to the concept here. And really, if the students don't understand the concept of what a cosine is, for example, they're going to really struggle on some of these problems, because they might look at this and go, okay, wait, cosine is 5. This side would be the, and that's 8. Like, wait a second. Why is that side 9, but I said it's 5? And they're not sure how to kind of deal with that. Does it make sense, Tom? Do you understand how students could be confused if they don't understand that cosine is really a ratio, that it's not the exact values of 5 and 8 there?
Right, and the fact that they don't have to use a calculator, they're taking that part out. They aren't telling you the angle and just saying,
right,
type in, what is the cosine of that? They have to understand that conceptually, yes.
Oh, that's a good point, too. This is, when I saw this, I thought back to one of our one of our activities. I'm going to go to education.ti.com. I just had it, but I just deleted it. If you go to activities, and this is one of the math-inspired activities. These have been around for a while. I just don't know if you've seen them, but in the geometry section, there's one about right triangles and trig, I think. Let me see, was that it? Yeah. And trig ratios, here it is. So if you download that activity called trig ratios, once I saw this, I was like, oh, that boils it down to the concept. That's what I need with my students, because I have some students that were just kind of mystified by that question. They're like, sometimes they even put the thing in the wrong place. They don't know what to do because they're like, wait, that side's 9. It's not 5. I don't understand. And this is an oldie but goodie kind of thing. And the way it's built, it's kind of one of those where what's changing, what's staying the same. And so if you move point B here, the angle looks like it stays the same, but the sides are changing, I guess we'd say proportionally. And that proportion always happens to be the 0.77766 there. And so that's kind of nice. You can see when you move that, it changes the values there. And then what I like is you can actually change it to other angles. So 45 degrees, it turns out, if you draw a triangle, a right triangle with a 45-degree angle, that ratio is always 0.707. I don't know why I think 60 is my favorite, right? Because it's 1/2. It's just so easy to see that when no matter where I drag this point, you can see that the pink side there is always twice as much as the green side there. And so you can just see that ratio, that it's not really saying that side, it's not really saying that side is 5 and that side is 8. It's saying the ratio is a 5 to 8 ratio. And then hopefully, students will set up, 5 is to 8 in the same way that 9 is to, E or whatever you want to call that side. And you cross multiply and solve that. I think the answer ends up being J there. But just getting them to get the concept, because if you don't get that concept, again, they'll sometimes, I've had a student do this when I watch them do this problem. They go, well, that one's 9. I guess this one is 5. They just kind of they come up with their own kind of reasoning for things. And it's, it gets kind of crazy. But if they don't understand the concept of a trig ratio, they're really kind of toast on that. And it's amazing. Tom, I've seen this with calculus students who are, they have the unit circle memorized, but they never learn the concept that the trig ratio is always the same for the same very angle. Does that make sense?
Yeah, no, and I just like that idea of them saying, I'm giving you the cosine, because like you said, that could just throw a student off and say, what do I punch into my calculator? Well, you don't. Right.
But I mean, the concept, again, is a very important concept there. Let's look at this one for a minute. I really like this. It's kind of a tougher question number 56 on there. And Tom, I really like eliminating answers for our students. Sometimes they'll come to a question like this, and it's pretty tough, and they might not know this formula. They might not know how to solve it. But I think even on a problem like this, you would be able to eliminate a few answers. Like I think most of our students would know 1/2 base times height here. And base times height, that's clearly not a 90-degree angle. I think F would have to go by the wayside there for the area, because it does ask for the area of that triangle. And then maybe they know the Pythagorean theorem. You think, okay, actually that would give you, right? That would give you this side, right? So that's not going to be the area, probably the side of that. And if you're familiar with law of cosines, because that's SAS kind of a case there, the side angle side. So it's law of cosines, d squared equals to that. So this one would actually be, I guess, this length as well. Is that right? I think that's right. I know that's law of cosines, and so that would give you this other length. It would, I think, yes. And so, again, that's the length of the side. So really, at this point, just without even knowing, it does help to know some of those things. Also, like other things that play into this, you think about how much knowledge they have to know to answer these questions, especially, again, you don't know the formula or something. Maybe you look at this and you think, is that a 90-degree angle there? And so if you know your 30, 60, 90 triangles, because this happens to be 30 degrees, right? If that's 30 degrees, that would mean the hypotenuse is 14, and that would be 7, and that would be 7 times root 3, and that's not 7 root 3. So I know that angle is not a right triangle, because I think sometimes students kind of like to jump to those conclusions, don't they, Tom? Like when some students, oh, it's got to be a right angle there because maybe it's 30,
and I'm
59.
surprised you used 30 here because, like you said, I would have thought the sine of 30 is half. So I'm surprised they used 30, that they'd had that angle in there.
Right, and the idea of drawing an altitude there and say, well, I know that actually is, so that height there is 90, and now I have a right triangle I could do. So you could set up, sine of 30, equals the height, I guess, over the hypotenuse of 14. And then just, of course, multiply both sides by 14. And you have h is equal to 14 times sine of 30. That looks like this right here. So that's our height. And then our base would be 12 and 1/2 base times height. And we've got it. If you know your formulas, this is one of those formulas that you don't talk about very much, but this one right here, I call it the SAS area formula. There might be an official name for it, but it's 1/2 B times C times sine of D, and it's really fast. But they don't learn that probably at earliest by pre-cal. Usually, it kind of depends on your school. But again, that's kind of an obscure formula, and it's not one they use a lot. So you could always derive it by drawing the altitude. But I think more and more on this test, they're requiring students to know law of cosines, know law of sines, and now even this. So I mean, the idea of making this an area problem instead of making that, how long is that side kind of a problem is a much different kind of thing there. I really liked it. Tom, what do you think of that one?
No, I liked it too. And in fact, I like drawing in the height. I would prefer not to memorize the formula because I'm not even sure kids who memorize formulas would even recognize it would apply here.
Right.
But I like drawing in the height because that's how I derive the law of sines, right? You derive the law of sines formula by drawing that in, setting all those equal, and that I just think that makes the students understand, oh, there's a reason why we derive those or why we do those things and not just memorize.
Sure. Let's look at this one. This, when I look back at the geometry stuff here, I didn't see a lot about rotations and reflections. Maybe I missed it there. But they didn't really mention that. But thinking about this problem right here, I don't know, I'm generalizing here a little bit, but if your school uses kind of older textbooks, I don't know how many years old, but a lot of the older geometry textbooks really don't have very much in there about reflection or rigid kind of motion rotations and things. Whereas the newer kind of geometry textbooks have kind of included that. I see that when I tutor students, geometry, this is a newer textbook. And so they'll talk about this kind of stuff. And so understand this is going to be on the test. So if you're using an older textbook, I want you to know that, what kinds of things you might see there. But go ahead and try this one. Just give it a second. And so let's see, if you reflect across the y-axis, so that's going to be, kind of this kind of a shape there. And then you could, one of the participants said there, you could actually rotate your paper 180 degrees and you'd see your answer. Let's see, so it rotates, you kind of picture that. So it would look, I guess like this after 90 degrees. And I think like this, does that sound right? It's kind of hard to draw. It's hard to think that way. And some students really have trouble just visualizing a rotation like that of 180 degrees or 90 degrees. And so, practicing that, seeing that. And they also get the X and Y axis. I think these would probably be labeled on the real test, X and Y. But sometimes they even mess up that part, the reflection across which axis here. Or they reflect across both axes, and it gets really kind of confusing at times. So once you know that kind of stuff can be on there, because, again, if you're not familiar with that, that's the case. Statistics and probability here are about 5 to 7 questions. And, you know, Michael Dorsey's on this. I know he mentioned to me when we talk about the new tests that come out, he said they always like to put a few probability, you know, a few stinkers on there, you know, just kind of like they're getting harder and harder. Some of the stat stuff, if you haven't taken AP stats or you don't do that much in your class, you might not know some of these terms. It's not that it's that hard of a problem, but the terms are difficult sometimes, like this one. So read that question there. By the way, I don't know if you agree with this. This doesn't sound like a very good question stats-wise. They only interviewed the people at the local country club. I mean, they didn't interview a random sample or anything. So right away, you think, was this random? Did they randomly select people? No, they just selected people at the country club. So you could eliminate, you know, randomized. This was not randomized. So students understand what that means. That would be, you know, I love the idea of eliminating answers here. So if they just even know that much. The other thing is an experiment or a survey. And students need to know that an experiment is something where you do something like you give someone a drug or you change your teaching method or you do something to them. Whereas this case, they were just asking them questions. It wasn't really something, there was no treatment group there. And so I don't think this was an experiment. So I think you could cross those two out. By the way, you would be expected to know what the word census means. What does census means? You probably know that just from, if you understand what a census is, you interview, you ask everyone, and that's certainly not what's happening. They're only asking the country club folks here. And so it's got to be a non-randomized sample survey. But again, just a lot of math terms there. And so if they take an AP Psych, that's another class that actually helps them understand some of this stuff because they understand like stratified samples or different things. And you'll see this, it sometimes gets to that level of using some of those terms. This is a classic example of a question. Here, go ahead and read this. So I think there were 10 numbers in the original list. It looks like the middle is right about there. So the median was 73. Haven't really figured out the mean yet. Not sure I need to. If we add a 100 to this list, so we add the 11th term, now this term would be the middle, right? The middle term, so the median was 73, it's still 73, so the median has to be one of the answers here. And really the mean has to change, right? The mean would have to get larger when the concept there is you're adding an outlier. That's really what they're testing here is, you know, the mean is definitely going to get bigger. And so it's not going to be the same. So those could be eliminated. And then mode is the most repeated. Sometimes students don't know, you know, the mode would be 76. They don't understand that word. Range is an easier term for students usually, and that'd be 100 minus 55 versus 82 minus 55. So that definitely changed. And so the only ones that didn't change would be the median, which we call that a very resistant measure. I think that concept of when you add an outlier of any kind, and I would use that term with your students when you're doing this, because the test may even ask if you added an outlier rather than giving you a number. They may just ask that. You know, understand that the median is very resistant to an outlier. It has little or no change depending on the data group that you have there. In this next one, before I get to this next one, I want to talk about one I've seen on the test that, like a much simpler version of this one, if that makes sense. So like if you have 3 red and 5 green marbles, and you want to pick out 2 red marbles, that would be, the first marble you pick out would be 3 out of 8, I guess would be the probability. And then the next marble you pick out would be 2 out of, and you probably know this, 2 out of 7 you want to pick 2 red marbles with no replacement, those are not independent events. And so you have to adjust it. I just thought this was a really tough stats problem dealing with this. This will be our last problem, I think. Hopefully we can get this in. And so the question is, which of the following gives the probability that both owners choose the same type of phone? But you almost have to break this down into 2 separate little questions. In other words, what's the probability of both having Androids? Right. So if you want that probability of having an Android, that would be 146 out of 300. And then you're going to multiply that by 145 out of 300, because once you've chosen the first Android, there's only 145 choices left. So that's where this comes from right here, which I thought was really an interesting part of this. And then you do the iPhones, and that's where this comes from, right? You have 154 iPhones. The second one could be an iPhone, and that'll be 153. Similar to questions you might have asked with cards about, what's the probability of getting all the same suit when you are at the 5-card poker hand? It's that kind of question. But they've stepped it up a notch from where they used to ask. Like, that's where they used to be. And this is a much tougher version of that same type of question, which is, anyway, I thought that was interesting there. Michael, I think we may be to the end here.
Sounds good, Jeff. Let me take things back from you if you're okay with that.
Yep.
Great. Thanks so much. So as we begin wrapping things up tonight, if you do have any last-minute questions for Jeff or Tom, please try to get those asked. I know they'll do their best to get those questions answered. One thing I do want to point out is with the link, the bit.ly link that will be shared, it was actually shared earlier. It'll be shared again here in the documents in a few minutes. I believe both Tom and Jeff's contact information is shared right at the top. So if you are watching this again as a recording in a couple of days and you have questions, I know that they're okay with you reaching out to them. To receive a certificate of attendance as well as a link for those documents that I was just talking about, go and click the links in the chat window. If you're watching this on demand, go and copy that link into your favorite browser to receive your certificate. And if for any reason these links aren't working for you tonight, have no fear, you'll automatically get a follow-up email. And that follow-up email contains links to the certificate, the documents, as well as the recording. If you have any post-webinar questions for us, feel free to give us a call at 1-800-TI-CARES or drop us an email, excuse me, ti-cares@ti.com. We'd love to hear from you. Lastly, when you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts. As far as upcoming webinars, we have a bunch. One that might be of interest to you is on April 6th. So if you visit our website, education.ti.com/TI webinars, you'll see that on April 6th, 2 people that you may know, Jeff McCullough and Tom Reardon, are also doing an SAT prep webinar. So feel free to check that out and register for that. Again, it is free. So big thanks to Tom and Jeff for everything you guys shared tonight. We really appreciate it.
Thank you, Michael. And I'm glad I made it from Denver.
Yeah, very good, Jeff.
And we're glad you made it too, Jeff. Thanks so much, everyone, for joining us. And we hope to see you back online next week. Have a great night.
Okay.